If you're fortunate enough to work in a company where you always have enough time and money to complete your projects, then this video isn't for you. Also, let me know where you work so I can send my resume. For the majority of us, we often have to make compromises to meet deadlines. And when the pressure ramps up, the most common thing to get dropped is quality assurance. And that means less unit testing. If you don't control where the compromises occur, they will occur at random. And inevitably, some of those compromises will occur in places you'll wish they hadn't. As a result, there's a lot of value in making deliberate decisions about where it's acceptable to compromise and where it's not. As an example, if you're an online retailer and your "share this product on social media" button stops working, that's an annoyance. However, if your credit card billing code suddenly has a bug that causes incorrect billing, the negative impact of the problem is significant. The solution, then, is to have a system in place to control where compromises occur. The first step is to establish criteria for test coverage. Like many categorizations, the extremes are pretty simple. At one extreme is no required quality assurance. At the other end would be a full suite of tests that cover every possible code branch, with examples of every possible category of input, both valid and invalid, and tests to verify load capacity and scaling ability, as well as fuzz testing. How many levels are in between and how those levels are defined can get complicated, partly because the definitions can be context dependent. For example, for a team developing back-end services, the two extremes might actually be all that's needed. Either a service is critical or it isn't. However, for a team developing client-facing code, there may be a requirement that new code at least have enough tests to ensure that it can't be exploited by bad actors, even if it's otherwise untested. Let's go through a fictional yet realistic example. Our team is required to add a custom user icon feature to our cloud app. Let's assume that this is some sort of forum or social networking application. Management has specified that this feature needs to be done ASAP, which generally means that we need to make compromises to improve delivery speed. The first thing to establish is the overall QA requirement for the project. In layman's terms, management needs to define the risk of releasing a new feature that doesn't work or works incorrectly. For this fictional example, management says it's okay if the feature doesn't work properly for the initial release. This sets our bar pretty low. The default standard for QA is no testing at all. However, there's still a bit more to define. Although it's acceptable for the new feature not to work properly, it's not acceptable for it to break pre-existing features. Therefore, the low bar is slightly higher. Existing tests must be extended to ensure they still pass when a custom user icon is in use. During design planning, the team realizes they'll need to implement a new image storage service to make the new feature work. As it turns out, a known future project will also need the image storage service, but the future project will require a high level of reliability for this service. As a result, work done on the image storage service requires a higher level of testing than the rest of the project. Another option is to create the image storage service with a low level of testing, and the future project will increase the testing. This is yet another compromise that needs to be considered. Once the various levels of quality assurance have been clearly defined and documented, developers can use those requirements during development and code reviews to ensure they're making the right compromises in the right places. By making the process of compromise deliberate, the chances of project success are increased and the risks associated with project missteps are minimized.